And I've got some tracer particles here in solution, sort of like food coloring. And I'm going to put a drop of these tracer particles on the film. This is after the film has had a chance to quiet down. Motion is pretty much confined within a two-dimensional plane, and it allows you to look at viscous flow in the laminar region in a two-dimensional manner without having to worry about flow in a third direction. So after I put these tracer particles in the film, I'm going to stick a Teflon cannula through the film and start stirring it up and watch the effect of the rotation. And just from that little stir, this thing will sit there and rotate for about 20 to 30 minutes. And I'll show a few minutes of the early rotation like this when it's rotating fairly fast, and then I'll go into time-lapse mode where I time-lapse it over about 20 more minutes, showing what the final effect is. But you can see that the flow is laminar here, and the tracer particles are very slow to diffuse and show nice streamlines that hang around for tens of minutes.
And Don, we're watching that, and that is a great video. That is such a cool phenomenon that you're showing us here.
And you end up with spiral lines because the rotational flow will we don't know what we're supposed to say there.
Copy. And it looks
rotational
like
flow will do something, but we don't really know what.
It looks like you're making a record there or something.
There's time-lapse mode. And this is a half a second every 30 seconds frame time. And you can see as time goes on, the lines do get more and more diffuse as diffusion plays its role and stir and fades up. And I let this run overnight, time-lapse. Unfortunately, the battery died on the camcorder, but by morning, the whole film was just a nice uniform milky white color, so diffusion had taken its role.
And it looks like we have a jellyfish up there.